What's up, you guys? Rex here. So I've officially survived 3 weeks of medical school and things are really starting to ramp up. So this was my first week really being in the classroom. My first 2 weeks had been of clinical immersion, so this is where I really dove in. I'm taking science-based courses, started anatomy, all kinds of really cool stuff. And I gotta say, I absolutely love it. It's totally different from undergrad in just every way of like the pace of the material, how the material's taught. And I think the biggest thing is it being pass-fail. And so it's just like so carefree, and I'm just focused on learning and absorbing things. And I'm actually learning things I care about compared to undergrad. And I gotta say, my normal week of undergrad, I might look back and feel like, all right, what did I learn? Not true at all with medical school. It's like, what didn't I learn? I've learned so much and I'm only 1 week in. So I'm really thankful that I did get to go to campus a little bit. I got to go to campus for my histology lab, which is like looking at things under microscopes, even though we had one day was in person, the other day was via Zoom, and in both cases we're looking at digital images, so it's not super necessary to be in person. But I did get to go for my first day of anatomy lab where we started dissecting our cadavers, which is an absolutely awesome experience. And I did record a video that was sort of my initial thoughts after that experience of seeing a cadaver for the first time. So I'll eventually get that up. Stay tuned for that. But in the meantime, I just want to do what I plan to do every Sunday of reflecting back on my week and share something cool that I learned as something for me to keep track of my learning and force myself to be thinking about all that I've learned, which I can tell you isn't hard to do because there's so much I learned this past week that it's hard not to think about all the cool things I learned. So I just want to share the one cool thing because it's sort of a little bit answered a question I've always had. Okay, so something cool I learned this week that I'd like to share with you is called Kiss and Run Fusion. So what this is it has to do with how cells communicate with each other. So potentially you've had some biology class where you've learned about neurons and action potentials, where you have some cell that has a body and it's got an axon and it's got an action potential that is basically a depolarization front that moves along this axon. And so I've always thought it's super cool, and I got to learn about in my biomedical engineering undergrad about sort of some of the mathematics and sort of like modeling this as a capacitor and stuff like that. And so one of the cool things I remember learning about is how an unmyelinated axon can have an action potential that travels across the axon at around 10 meters per second, although usually a little less. But it does a cool thing with myelination and nodes of Ranvier that can get it to travel at like 150 meters per second, which is so fast. Like that's going from the bottom of your foot to your spinal cord in under 1/100th of a second, which is just cooking. And so I've always thought that like that's super cool, but then wondering sort of why that happened, as far as in order for that to go super fast, the only advantageous reason for that to happen is if it's not the rate limiting step in the system. And so I've always sort of wondered why the rate limiting step doesn't occur at like a synapse here, where you have a little vesicle filled with a neurotransmitter, which has to find its way to the cell membrane, merge with it, open up its contents, and then have those little neurotransmitters diffuse across the membrane and then get picked up with some receptor on this end. And so this is like the receiving cell. And so it knows that an action potential has happened over here, and it says, okay, receive the message. And so like this whole process on this side has to be as fast as possible. And so it makes sense that like action potentials would have all this stuff with maintaining concentration gradients and all this stuff a cell does to make it as fast as possible. What does the cell do to make this as fast as possible, that it's not just like such a rate limiting step? And up to this point, I had never learned about anything cells do to make this as fast as possible besides having this little synapse, synaptic cleft area really small so that this diffusion happens almost instantly. But what about this process? So this week, I learned about KissandRun Fusion. And so basically what this is, and after doing a little bit more Googling, it's not 100% agreed upon on scientists as far as this is happening, but I learned about it at Duke Medical School, so I will assume that's a very reliable source, and it makes a ton of sense to me. And so what this basically is that once a vesicle is filled up with its neurotransmitter or whatever its contents are that it's supposed to be releasing, and it gets tagged with whatever appropriate markers, it enters into this sort of loop of where it joins onto the membrane here and sort of gets primed and ready to go. And then it does this little kiss where it opens up just a little bit and maybe lets out like one or two little bits of its contents. You know, some percentage that I don't know if they have any way to quantify if it empties an eighth of its contents or a tenth or something like that. But it empties a little bit and then it runs away. So it does a little run and then it does a little kiss here. And then it comes back and it's ready to go and enters the cycle all over again. And so this has the advantage. So this has the advantage of recapturing all of this membrane. So none of the membrane of the vesicle is lost to the larger cellular membrane, which would make it grow, and then the cell would have to find a way to get that material back to reform these vesicles. But the biggest thing that makes sense is that the cell is at all times sort of primed and ready to go to receive this action potential signal. So as soon as it gets there, that there's already a cell which is like in this position, which is in the process of opening. And so that makes so much more sense to me that once this action potential gets here and travels along the membrane, that there's a way, okay, now it's got the signal, all right, boom, instantly, instead of doing your little kiss and run, time for you to do a full open and release all of your contents to this other side, and it's ready to go. And so that's at least one way that we somewhat know of. I say somewhat as far as it's not 100%, but we think we know of that helps the cell improve this part, which maybe otherwise would be a rate limiting step. So if any of you happen to be experts, I'd love to know if you know sort of like a time frame of when this event happens on, and especially knowing it on that, like, this action potential propagation step can be like on the order of hundredths of a second. That is this on the order of hundredths of a second too, which is why this had to go through some evolution, that there's a reason to go from unmyelinated to myelinated, that you actually gain a significant time saver on the whole process. I'd love to know. Maybe you guys know. I look forward to learning it. Maybe I'll just learn it next week. Who knows? But I'm really excited, and I thought Kiss and Run was cool. So that's how KissandRun Fusion works. So I hope that was cool for you to learn about. It was definitely really cool for me to learn about. I hope you actually did learn something. And so I'll be continuing this every Sunday going forward, just reflecting on my week and sharing a little bit of something tangible that I learned, and hopefully sharing it in a very simple way that some of you can get something out of and just learn something cool that your average medical student learns in an average week. In addition, going forward, I'll be uploading probably on Wednesdays and Fridays. Things are getting busier. I'm definitely like in the thick of it now, so I'll probably pretty soon be switching down to just one extra upload a week, so maybe on like Wednesdays and Sundays. But this coming week, you should expect a video on Wednesday and Friday. So if you want to make sure you catch those, be sure to subscribe and stay notified. I'm planning, I think, that I'll do a video on revealing my GPA and all of the courses I took to prepare myself for medical school, so all of the pre-med courses, but in addition, just going over all of the courses I took in undergrad and revealing what was the hardest, what was the easiest, what course I got my worst grade in, and all that kind of stuff. So make sure you're staying tuned for that. As always, if you have any questions, comments, or concerns, I'd love to hear about them down below, whether it's some video you'd like me to make or any comments about anything I said in the video, any corrections. I'd love to learn more about it if you happen to be an expert, because it's really cool to me. That being said, like the video if you like the video, dislike the video if you dislike the video, and until next time, don't be ordinary, go be great.